Hello, welcome to the next video in stoichiometry, and in this video we're going to do what's called mass stoichiometry. Now in mass stoichiometry, what we do is we are calculating the mass of one of the substances in the reaction by using the equation and the mass of one of the other substances. So basically we're given the equation and we're given the mass of one of the substances in the equation, and we need to be able to calculate the mass of any of the other substances in that equation, and that's mass stoichiometry. So we're going to be using this equation on your formula sheet that we've used before and we're familiar with, where N is the number of moles, M is the mass in grams, and capital M is the molar mass of the substance, and that can be rearranged into these two forms. Okay, and we've had practice at using this equation. So there are 4 steps basically in the first method that I'll show you, and the first method is to write the balanced chemical equation, identifying the known substance and the unknown or required substance or substances. Calculate the number of moles of the known substance, so we need to convert it into moles if we're given a mass. We then use the molar ratio that states the portion of known to unknown quantities in the reaction, and use it to calculate the number of moles of the required substance. So this is where the molar ratio comes into play. We then, now that we've got the moles of our unknown substance, we then calculate the mass of the required substance using our formula. So let's do an example. Some sulfur is present in coal. When we mine coal, there's things called pyrites in them, which have the formula Fs2, also known as fool's gold. When we burn pyrites, i.e. when we burn coal, the pyrites pollutes the air and produces sulfur dioxide and solid iron 3 oxide. So here we're told the information: what mass of iron 3 oxide is formed from the complete combustion of 183.5 grams of pyrites, FeS2. So the first step, working through our steps, is to write the equation, and here it is. Hopefully we recognize that oxygen is O2, and then we work out everything else and then we balance it, and so we actually have a fully balanced equation there. And our known is, just to identify our known is the FeS2, alright, the pyrites, and the unknown is the iron 3 oxide. And if we just jump back one, sorry, I thought it was mentioned in the next one, but our ratio is 4 is to 11 is to 2 is to 8. And for our known to unknown in this question, our ratio is 4 is to 2. And so we effectively can ignore the other 2 because we're not asked about it. But we could have been. So now that we've got to convert the mass into moles, so we would divide by the molar mass of FeS2, and there's our calculation, and we get 1.529. Careful not to round too soon, because we want a degree of accuracy in our calculations. Next step is use the molar ratio, and in this case the ratio is 4 is to 2 now, which simplifies down to 2 is to 1. You can use 4 is to 2, you can use 2 is to 1, your choice. And they do a little bit of maths technique here, but basically it's saying if our known is 1.526, so I would actually be more tempted to, let's see, what colour have I got here? That should work. I would tend to write it something like, this is just the way my mind works. 4 is to 2, which is the same as 2 is to 1, and if our known is 1.529, okay, effectively this has to be 1.529 divided by 2. So we would divide it by what we're given there, half of it basically, and so that becomes 1 is to 529 is to 0.7643. Notice all the decimal places because we want to maintain some accuracy. And this is basically what they've done here in their maths sort of way. Hopefully you understand that. Let's move on. So now that we know the mole of our unknown, is that right? We can then work out the mass. So this is where our moles of our unknown goes, or our iron 3 oxide. This is the molar mass of iron 3 oxide, and it works out to be 122.1 grams. So again, just using the same formula, but putting in different values. So you really got to keep your mind on the ball as to what numbers you're using and why you're using them. Basically, what step are you at? Now, an alternative way of doing it is effectively the steps are the same, but you just present it out a different way, and you actually find the molar ratio before you convert to moles. And so this is a visual way that I sometimes set it out as well. So there's our equation. That's our known. That's our unknown. Our molar ratio is 4 is to 11 is to 2 is to 8, but we're only interested in the 4 is to 2. So first of all, we work with our known. We've got a mass. We need to convert that mass to moles. So we divide by the molar mass and we get that answer. Okay, now, ooh, my calculator, my laptop's going to crash on me. Running out of power. Once you get to the mole, you can then use the molar ratio, which is 4 is to 2. Therefore, you need half the moles of the known. And so for your unknown, half of that, you get that value there, and that's going to be times by the molar mass for iron 2 oxide. Therefore you do that step there and you get the answer, and these little arrows guide you through the process, okay, from known to unknown. I like setting it out like that, but other people like to set it out their own way. There's no convention as to how you should set it out. So you should now be able to have a go at these questions. Don't be worried if you find them a little bit confusing to start with, but with a couple of them, after doing a couple, you should see that you're doing basically the same thing over and over again. So we give you quite a few of these to do, and in the next video we're actually going to look at solutions. See ya.